Hi, this is Dr. S. Dhanapal, Associate Professor, Computer Science Engineering in Communal College of Engineering and Technology, Trichy. Okay. Today I am going to explain the concept of data structure, small definition with the simple examples of linear and nonlinear data structures. A definition: data structure is a way of organizing, storing, and retrieving the data in the relationship with each other. Already we have a basic concept of data and the structure. Data is nothing but any information is called as the data. Then structure is a way of organizing the data is called as a structure. The combination of data plus structure is called as a data structure, is called as a way of organizing and storing and retrieving the data from a database is called as a data structures. Okay. So take a small two examples. One is a stack and another one is a queue. Then both are used for the linear data structure. Just in next chapter, I will explain the concept of linear and nonlinear data structure. In the stack, you have the locations, array locations start from the 0th to 1 by 1. Okay. The 0th location, you can store the data 5, the next location 6, third location 9, and final one is 2. This is the stack. Then queue, you are using two positions, front position used to delete the element and rear position used to insert the element. Suppose I want to insert the another element to the queue using a rear position. If you are insert the data in the fifth location, insert the next data. Okay. Then classification of data structures. In this classification of data structures, you have two important types. Data structure is a primitive and non-primitive data structure. Primitive data structures have four important types: integer, character, float, and boolean. A non-primitive data structure, we have a linear and non-linear data structures. Under the linear data structure, we have important concepts: array, linked list, stack, and queue. And non-linear data structure, we have important concept of tree and another one is a graph. Okay. Abstract data type. Abstract data type is nothing but set of operations in the linear and non-linear data structure is called as a abstract data type. Okay. Take a simple example. If the list, stack, queue, these are the linear data structure. Under the linear data structures, you have a list, you have operations, insert, delete, and find. These are the some other few operations under the list in abstract data type. And non-linear, then stack, you have important operations: push, pop, is full, is empty. These are the some other few operations under the stack. Okay. This is called as an abstract data type with the operations. And another one is a queue. Under the queue, is important operations: enqueue, dequeue. This enqueue is nothing but is a insert queue, delete queue, dequeue, and is full, is empty. These are the some other important operations belongs to abstract data type. Okay. Then list abstract data type. The list abstract data type can be represented in two ways. Okay, represented in two ways. One is array and another one is a linked list. In array, you have two important positions. One is array index and array elements. Okay, this is called as a static memory location. Linked list is called as a dynamic memory location. What is static memory location? Just it's a allocated the memory location in position and insert the one by one data. Okay, if the linked list is a insert and allocate to the memory location in runtime, whenever you want to insert the any new element, allocate to the new memory location and insert the data. It's called as a linked list. Okay. Then array abstract data type. Just take a simple example: integer and array of 6. Okay, here ARR is nothing but is called as an array variable. Then is called as an index of the element to be accessed. Okay, is a index of memory location. Okay, take a simple example here: integer array of 6. I allocated the 6 memory locations. Then allocated only possible data. If you want to insert the data bit, so only possible maximum 6 elements is inserted to the array is possible. Okay, then array of 0th location, you can insert the first element. Then array of first location, you can insert the next element. Then second location, insert the third element and fourth element. And fourth location, you can insert the fifth element. And finally, on the fifth position, you can insert the sixth element. Okay. Then array of 0 is nothing but array of 0th location to start from 1 by 1. All the locations you can insert the data. Okay. The issues in array. What are the main drawbacks of the array? It's a fixed size. Resizing is expensive. Okay, it's a only fixed size. So fixed means it's a static allocation. Static allocated to memory location is possible. Only maximum fixed size data element is possible to insert the data memory locations. Require continuous memory location for allocation. Difficult when array size is larger. So if we are Array size is large, it's very difficult to access the information from the memory locations. Okay. Then next, another important type, linked list abstract data type. It's called as a dynamic memory location. Okay. Whenever you want to insert any element, means just allocate the memory location and insert the data to the particular memory locations. Okay. Linked list is a linear data structure. Is made up with a chain of nodes. Okay. It's called as a linear data structure. Okay. Then array and linked list both are the linear data structure with the concept of made up chain of nodes. The nodes is nothing but just one node is connected to the another node, then another node is connected, next node is connected to the next. So one by one you can insert the data. Okay. Each node contains a data and a pointer to the next node in the chain. Okay. Last node of the list is pointed as a null. First element is a head position and last position is a tail position, otherwise null position. Take a simple example here is a node. In this node, you have two positions. One is the element data position and another is a link of the next node positions. Okay, it's address node. Okay, first one is a data field node, the next one is a address field node. Okay. Then address is connected to the next node 23. Then connect one by one randomly. You can sequentially insert the element one by one. Representation of node in a linked list. Each node contains two fields. Data field contains a data element to be stored. Pointer field contains the address of the next node. Data field is nothing but the actual data inside the data positions. Then pointer field address of the next node. Address of the next node data, next node address can be stored in the previous node. This is called as a node. Declaration of node. Under declaration of node, struct and keyword is a structure. Keyword is a node. Struct keyword with the structure name is a node. Open parenthesis and close parenthesis. Within the semicolon, you can insert the the node values. Integer data, struct node, pointer of next. Creating a node. How to you can create a node? If you are creating a node, then only possible to insert the element to the particular node. Statement to create a node, n struct node, pointer of memory allocation is a malloc is nothing but memory allocation size of the struct node. Already we have allocated the struct node. You have two positions. One is a data position and another one is a next position. So if you are allocated the memory location, in this memory location you have two positions. One is the data position and another one is the next position. Then here mention the name pointer of n equal to the node name is the whole node name is the n. Okay. Then n dot next equal to null as a null. Types of linked list. You have three important types of linked list. One is a single linked list, double linked list, and another one is a circular linked list. These are the very important linked list types in the memory location. So dynamic memory location. Single linked list. So single linked list is short name of SLL. Each node contains only one pointer field that contains the address of the next node in the list. Take a simple example. Here you have a is a node 1, node 2, node 3, and another one is a node 4. You have a 4 nodes. First node you have a 2 positions. Node have a 2 position. One is the actual data position 83. Then it's called as the address of the next node. Okay. Then address of the next node. And here is actual data position, address of the next node. Then here you have a third data. 27 is the actual data, address of the next node. Then 46 is the actual data, address of the next node is null, so it's called as a no address location. Okay. Then here you have a first node, the address location is 1000, the next node address location is 85, then third data address location is 1500, and final data address location is 2500. If the first location address location you can store the 850, then second node the address location or address location you can store the next address location 1500. Then third data position 27, the address location next node position address location you can insert to the previous node. Then final one is the no data you have the next position, so it's called as a null position. This is a single linked list, simple example. Then operations of single linked list. These are the main operations of single linked list. inserting at the beginning. Inserting is the possible in the node in the three positions. One is the starting position, insert the data. Other is middle position, insert the data. Other is last position, insert the data is possible. Then deletion is have three important possibilities. One is that at the beginning position you can insert the data, and otherwise at the middle position you can insert the data, and the last one is at the end of the position you can insert the data. And search, display, these are the few operations under the single linked list. And global declaration of node. How to you can declare the node in single linked list? Struct is a structure keyword. Node is a structure name. Node, open and close parenthesis, you have a declaration part. Okay, you have declare the integer data positions, struct node next position. You have only two important positions in the node. One is the data position and address of the next positions. Okay. Then integer data, struct node, pointer of next position. Then pointer of head, point of tail, point of n and t. Here you have an example for routine for inserting at the beginning position. It's a simple example. Begin inserting the data in the beginning position. The simple example void insert behind the function. Just in this function you have a n equal to struct node and memory allocation size of the struct node. Already allocated the memory location. Under the memory locations you have a two positions. One is the data position and the next position. Okay. Now you can insert the element in the starting position. So n dot next equal to null, n dot data position equal to number. Okay. N dot next as a null, then n dot data position is a number. Insert the number. If head equal to null, it's no problem. First you can insert the starting position, beginning position. The beginning position first element is the starting element. You can insert the data. Okay. Then otherwise move to the else statement. You can first location insert the data. After first location have a link with the new data positions. Okay. This is called as a concept. Okay. Take a simple example, n equal to head equal to head and tail. You have both have one. You have only one beginning position. You have the insert the data tail, insert in the data position. Then next position is a null. Okay, because you can insert the beginning positions. Okay, if you have take an example 10, just already have a three data in a inserting position. One is 83 and 9 and 27. Now I want to insert the new data. Listen, new data 10. I want to insert into the first positions. So listen, 10 is inserted to the first position, then have a link with the next data. The next data address location is 1000. This 1000 is inserted to the new positions. The C head position. Okay. 1000 is inserted to the this position. It's a simple example of inserting the beginning position. Next one, say inserting in the at the end positions. Void inserting end, struct node, memory allocation, size of the struct node, n equal to, just have a same example, same concept. Okay, just if you want to insert the data means first you can allocate the node, allot the node, then after the particular node insert to the last position, otherwise mid position, otherwise beginning positions. Already we had an example, we had discussed about the begin how to can insert the data in the beginning position. Now we are discussing about the how to can insert the data in the last position. Okay, then n dot next equal to null, n dot data equal to num. Okay, it's a number. Okay, if head equal to null, that's no problem. Just insert the first element. You can insert the element is the first position is called the first position, mid position, last position, all the position you have a same position. So no problem. Head equal to n, then tail equal to n, then insert the data. Otherwise, else statement, tail dot next equal to n, then you can insert the data tail position. Okay. Take example n, just allocated the memory location. Node, in this node you have a two positions. One is the n equal to node equal to two position. One is the actual data position and another one is a null position. Otherwise another one is the address of the node, next node position. Okay. Now head equal to just allocated new memory location with the data, then 10. Now I want to insert the data in the last position. Okay. So take a simple example. Already you have a three data. One is a 83, the next one is a 9, and third data is a 27. Now you can insert the data in the end position. After the 27, you can insert the data, new data is 10. Okay. Just to see 10 inserted. Now it's called as a 10 position. You can insert in the last position. The next position is a null. Okay. These are called as a routine for inserting at the end position. The next one is a routine for inserting at the middle position. Middle position means, here take a simple example. Here already you have a data 83, 9, 27 and 46. Is it possible, you have a possible to insert the element in the 83 after you can insert the it position, otherwise 9 after you can insert the next data, otherwise 27 after you can insert the new data 10. You have three possibilities. Okay, if any one location you can insert the data is called as a middle position. So void insert and the middle position. N struct node, remember allocation struct node, if next dot null equal to null, then n dot data equal to number. For t equal to head, t not equal to null, no? T not equal to null means t dot next insert the position. If t dot data mid data position, just insert the data in the mid position. Otherwise, move to the next one. Just see 83 equal to 9. Okay. Now 83 equal to 9. Just first you go to search the positions where you can insert the data. If they insert the data after which position. Okay. If 9, first 83 equal to 9. Now I want to insert the data, new data. Okay, listen. Now insert the data 83 equal to 9. It's not a memory location or same. Just move to the next location. No, next location 9 equal to 9. Yes. After the 9, you can insert the new data 10. Okay. Now 10 is inserted to the new position here. Okay. So the address of the next node 1500 move to the mid position 1500 insert to the address of the previous node. Okay. Then have a link, then automatically just move to the link 300. 300 is the new node address. In this 300 you can insert to this position, then create a link to the 10, then create a link to the 1500. Just remove, create a link, then move to that side. Okay, it's called as a mid position insert the element to the linked list. At the group for deletion at the beginning positions. Okay, next I want to insert. First we can insert, discuss about the how to you can insert the element in the single linked list. Under the single linked list, you can insert the element in the. You have a possibilities, three important possibilities. One is the insert the data in the beginning positions. Otherwise, insert the data in the end position. Otherwise, you can insert the data in the middle position. You have three important possibilities. Now we are discussing about the how to you can delete the element in the linked list. You have a possibility, same possibilities. Delete the data in the starting position, or delete the data in the mid position. Otherwise, delete the data in the last positions. Okay. Why delete behind? T equal to head. Okay. Then head equal to t dot next. Now free. The free means the remove or erase the particular location, the data with the address of the location. Just to see, this is a simple example. If suppose I want to delete the data 83, okay, t equal to head. Delete data is the same location. So remove this data from the memory location. Then assign next t dot next position. T dot next equal to t dot next equal to 9. In this position, assign as a head position. Then routine for deletion of the end position. Now I want to delete the element in the end position. End position is no problem. Just to remove the data or remove the node from the memory location. Then previous node assign as a address position, assign as a null position. Here take examples 1000, 850, 1500 and 2500. You have a 4 address locations with the data is 83, 9, 27, 46. Okay. Now I want to delete the last position. 46 is the deletion position. Remove the location, remove the data from the memory location and previous location assign as a null position. Okay. So tell, because if you have deleted the last position, the previous location address node is a null position. It's called as a routine for deletion at the end position. Just to see the function routine struct node pointer of TP, T equal to head, while T dot next equal to null means no problem. Just TB equal to next assign as a null position and move to the free position, and previous port address position is assign as a null. Okay. Then routine for deletion at the middle positions. Now we are discussing about the delete the element in the mid positions. Okay. Here take examples. This is address 1000 is the address of the 1000 is the address of the first node, 850 is address of the next node, 2800 is address of the previous node, so one by one. Okay. Next node, this is the 1500 address of the next node for 70 data. Okay. Now I have four data. One is the 83, 9, 70, and another 27. Okay. That's I have another one data 46. Okay. Now want to delete the element in the middle positions. Okay. First you can search the element. If the element have a particular memory location, remove the element from the memory location and create a previous location to the particular next location. It's called as a routine for deletion at the middle position. Void delete mid struct node pointer of TP, T equal to head now, while D dot data equal to now. Okay, just you are assigned to the next, otherwise you are assigned as a delete position. Okay. Take an example 83. Okay. Then now I want to delete the element. Okay. 83, just I want to delete the element 83 compare with the 70. 70 is the deletion position element, 83 is not equal to 70, so the deletion position is not in the first position. Next move to the next position, 9 compare with the 70. 70 is a deletion element, 9 is in the address location, so both are not correct, not the equal, so move to the next position. So 70 compare with the 70, the elements are same or not, it's both are same, so delete the previous location, delete the particular location, particular node from the single linked list, then address of the, remove the address 2800 because the next element 2800 is the address location, remove the element, then move to the next location 1500 insert to these positions. We just see 1500, then this remove 70 and 1500 address location, sorry, 70 data element position is removed from the single linked list. The next location 1500 insert to the previous locations. Okay. It's called as a single linked list. Delete the element in the mid positions. Okay. Search element, routine for search element. Struct node search T equal to head, while T not equal to null, it's no problem. Okay. Just you have T dot check the one by one. If the T equal not equal to null, just move to the next position and one by one return to the end position. Okay. Just here I want to search the element. Okay. Which element I want to search? Search the one by one element found or not. Okay. Now I want to search the element 9. Okay. 9 equal to 9. Okay. Listen, first you can search T equal to null. T not equal to null. Yes, not equal to null because you have a 4 elements in the single linked list. First element is 83, second element is 9, and third element is 27, and fourth element is 46. Okay. Now the address locations are, first location is 1000, then 7 locations are 850, then the 850 address location stored to the previous memory location, then 1500 is a memory location and insert to the previous memory location, and 2500 is memory location insert to the previous memory location. Now compare to the T not equal to null, yes, then 83 compare with the search element 9. Okay. If not equal to 9, yes, then move to the next. If T equal to null, not null, yes, not null because you have a element 9 in this memory location, then address of the next node is 1500. 9 not equal to 9, no, so element is found in the second memory location. It's a search element in the single linked list. Okay. The linked list, what are the advantages we have under the single linked list? The main advantage of single linked list, no wastage of memory, because whenever you want to insert the any element in the single linked list using a single linked list, allocated the memory location, after you can insert the data. Suppose you are using a array location, just first you are allocated the memory locations. Okay, suppose sometimes you are use only one memory location, remaining all the memory locations are empty, means the wastage of memory location. But in the linked list, no wastage of memory location, because your runtime you allocated the memory location and insert the data. Okay, memory allocated and deallocated as per the requirement. Efficient insert and deletion is operation. Efficiently you can access the information from the memory locations using insert and deletion operations. Drawbacks. There's few drawbacks you have under the linked list. One is that occupies more space than array to store your data, because you have store memory location using a array implementation. Just you can only array location with the address of the location. But here you have a link between a one data to another one data, then another one data. It's a chaining link between a data to data. So huge memory locations are allocated and store the data. So it's a main drawback of the disadvantage of the linked list. Okay. Okay, these are the few important concepts you have under the basic concept of data structure with the linked list. Just I'm going to review the few important concepts under the data structures. Okay, data structures is a way of organizing, storing, and editing the data in relations with each other. Okay, based on relation, you can store the data in your memory locations. Using a data structure, you have two important types. One is a primitive and non-primitive. Under the primitive, you have a integer, character, float, and boolean. Non-primitive, linear, non-linear data structures. Okay. Just linear, you have a important types, and non-linear data structure, you have a tree and graph. Okay. Now, most probably all the concepts you are using under the non-primitive data structure with the linear, non-linear data types. Abstract data type is nothing but it's a set of operations you have the linear and non-linear data structure is called as the abstract data type. Okay. These are few examples of abstract data type with the operations of list, stack, and another is a queue. Okay. Then you have two important implementation of represented in two ways. One is array and a linked list. Array is a static memory allocation method, and linked list is a dynamic memory allocation method. It's nothing but linked list of implementation. It's whenever you want to insert the data, first you can insert the allocate the memory location automatically, allocate the memory location runtime and insert the data. Okay, it's called as a linked list. Array is a static memory location. First you can allocate the data, allocate the memory location, and you can insert the data. Okay. Array abstracted. Just is a simple example of array with the allocation. Issues of arrays, it's only fixed size. It's not possible to resize the particular memory locations. The linked list, you have a linked list is called as a linear data structure made up with the chain of nodes. Okay. In node you have a important positions. One is the address position and the data positions. Okay. In this representation, this is a simple representation of node. In this node, one is the data position and the address of the next node. Okay. Then there are a few important concepts under the linked list. One is a single linked list types, then double linked list, and another is a circle linked list type. Okay. These are the single linked list. You have operations. The single linked list operations, you have a insert in operation, deletion operation, and search display. These are the few example operations of single linked list. Then each operation you have a three important concepts. Insert in chart you have a three important concepts. Beginning at the end, insert the data in the beginning position, middle position, the end position. Deletion the data you have a beginning position, middle position, or end positions. And these are the few examples of inserting, deletion, and in a single linked list. And just we are discussing about the data structure with the linked list. Advantages, disadvantages. Advantages: no wastage memory using a linked list, but you can use the static memory allocation. It's a wastage of memory locations, but here no wastage of memory locations. Then allocated memory location, deallocated memory location, the runtime is possible. Then drawback of the linked list is a occupy the more space than array to store the data, because if you have a data with each and every node you have a two position. One is a node position, address of the next node position, then address next node is a link with the next node. It's one by one is the one drawback of the linked list. Okay, thank you to all.